All right, friendly reminder, aside from the syllabus quiz, that's the only quiz you can take at home, but no other quizzes you can take at home. So even if you're absent, even if your computer didn't work, even if all that stuff, you cannot take quizzes at home. I can see what time you turn them in. If it's not during this class period and like you being here that day, then you can't do it at home. Even if someone gives you the password, no, I need to be able to supervise you. You can still use your notes on it and stuff. When you do return from your absence, you just have to make sure you're ready for it. All right, anyway, I asked you to pull up lesson 4. We'll start there just to make sure we understand. Also, I'm hoping that I can do this more often, actually go over some of the practice with you, so that one, it encourages you to do it ahead of time so that you're prepared with questions if you come into class. And 2, just in general, like I know it's hard to get all of you to turn in your homework all the time because it's only worth 10% of your grade, but it helps you with that other 80% of your grade. That's all based on accuracy. So that's why I want to stress more value on the practice. So raise your hand for whichever one you want to see. We'll do 1 or 2 before we start. Camille? Number 2. So if you want to follow along, you'll get the answer, and hopefully also, if you didn't understand it, now you understand it. Or if like your computer's not working, maybe jot it down somewhere on your notes so that you have it for later. But this is the lesson 4 practice, number 2. So a computer costs $800. It loses 1/4 of its value every year after it is purchased. Complete the table to show the value of the computer at the listed time. So we have been looking at exponential functions. That's going to be the theme for this whole unit. What's the formula for exponential functions?
Y equals a
Good. Now, I showed you 2 actually. I showed you that one and this one. Still, if you think of like if it's decreasing, that it's a negative, then yeah, you can still use the top one. The top one is usually showing what type of exponential function? Growth or decay? Growth would be the top formula. The bottom one would be decay. So what type of situation is this? Is it increasing over time or decreasing over time? So growth or decay? Okay, so for this one, we're going to focus on this formula. And it's losing 1/4 of its value. So the Y is usually like your output, whatever it is you're trying to solve. The A is for what? Starting amount, which in this problem is, yes, started at $800. And then it loses 1/4 of its value. That goes where? For the R or the T? For the R. So what it decreases by, we call the decay rate. Usually we put it as a decimal. Yesterday's lesson was fractions, so I'll just leave it as fractions. But yeah, whatever it's decreasing by would be the R. The T is for what? Time, and this time we're gonna plug in 0, 1, 2, and 3 for the T, and then fill out the table. Now, 1/4 is what we're losing. So what is remaining with 1 minus 1/4? 3/4. Just FYI, you could type in all of that into your calculator, but that's why yesterday we were putting what's remaining in the parentheses or timesing it by what's remaining, because that's what attached to that when you subtract it from the 1. Question so far? All right, then use a calculator, and each time you're just changing the value of T. So the one in here isn't bad. You could also use Desmos, and then it's really easy because you just have to change the exponent. So 800 times 3/4. And then to the 0 power is the first t that it wants. So that's what it looks like before I press enter. Everyone see that? All right, and then press enter, it's 800. Probably could have done anytime t is 0 without having to do the math, because that's always your starting amount. When time is 0, before it's decrease or increase, it's whatever it started with. And then you just keep doing the same thing, but changing the exponent. So like 800 times 3/4, put it in parentheses because it's a fraction, to the what power this time are we trying to find? 1, because we're filling out the table. Press equals, that value is 600. Make sense? Okay, then keep going. 800 times 3/4 to the second power. That's 450. And then one more that we have to find. 800 times 3/4 to the third power is 337.5. That will accept the answer like that, but ordinarily, like if we're talking about money, just make sure it looks like money. So I would probably put like another 0 there, like 0.50, but the rest, like, keep it the same. So it'll accept either this answer, or you can just leave it as a 0.5, that's fine. Yeah, it's because it auto grades. So you might have it right, but if you put like an extra space or if you put like a $sign, it will mark it wrong. So you could tell me and I could give you the point back, or like especially on your quizzes and your practices too. I usually just let it auto score. I don't know that it'll mark something wrong unless you tell me. So questions? All right, we can do one more from the practice. Jessica, I know you had your hand up. Okay, yeah. So number 5 from the practice. So lesson 4. So a piece of paper is folded into thirds multiple times. The area A of the piece of paper in square inches after n folds is A equals 90, parentheses 1/3 to the n power. What's the value of A when n is 0? So this one, it gave you the equation, so that's nice. Otherwise, yesterday and the day before, we went over how to find the equation. It wants n to be 0. So guess what? Replace the n with 0. What's going to be my answer? 90. And if you haven't noticed, there's kind of a trend. Whenever the exponent is 0, what's the answer for the output? Well, yes, anything to the 0 power is 1, which then it becomes 90 times 1, which is just 1. So it just becomes whatever the A was, whatever your initial amount was. Or just do the math and get the same answer. Then how many folds are needed before the area is less than 1 square inch? So that one, I did try solving it by plugging in 1 where? The A or the N? The A, because it wants to know when the area is 1 square inch. Exit out of it completely, or like continue, follow all the prompts. Like, does the time run out? Yeah, that would be done.
Because when I was trying to pick the first time, like, come up with a time. Yeah.
Give me 1 minute. Okay, so how many folds are needed before the area is less than 1 square inch? So yeah, that's talking about area. It wants to know what the number of folds is. So the N would stay N. 1 would go into the A. I tried solving it that way, but that requires some algebra that you guys, I mean, maybe some of you know, but that I haven't taught you yet. So I decided to solve it a different way. And the way that I decided to solve it was by making a table. We already know when N is 0, so N I'm kind of also interchanging with X, that's the number of folds. Because that's independent. Area depends on the number of folds, so that's my Y. We already know that when N is 0, that the Y is 90. So what other numbers could I test by plugging in and see if my area is less than 1 square inch? Should I plug in like negative numbers? No, why not? What is the N supposed to represent? So can I have a negative number of folds?
No.
Can I have a decimal number of folds? So I should be testing whole numbers. So like what whole number do you think would probably be close if when it's 0 it's 90? Okay, let's try 3. So plug it into your formula. I have 90 times 1/3. And we're trying to the 3 power, just to see what we get. So everyone do that, plugging in 3. We get 3.33 repeat. Now, that's not less than 1 square inch, is it? So let's try something else. What else do you want to try?
5.
Okay, let's try 5. So I wouldn't try 1 or 2 because those are in between the 90 and the 3, right? So that wouldn't give me my answer. Let's try 5 and see what we get. So 90 times 1/3 to the 5th power is what we're trying. And we get 0.37. Is that less than 1 square inch? So that's probably my answer. I'm still gonna test 4 because we want to see when it becomes less than 1 square inch. So I'm just gonna see if that one works. So 90 times 1/3 to the 4th. And that's above 1. Okay, so it begins to be smaller than 1 at what N value? 5. So that's what you're typing in. Don't put 5 folds, just put the number 5. Don't spell out 5. Put the number 5. I've done today. All right, questions? All right, I'm gonna put up the warm up for today's lesson. So that's enough reviewing the practice. If you have separate questions, you could always ask. But we're gonna start the actual lesson now. Hopefully by doing that more often, we'll get better scores on the quizzes and homeworks. So here's the warm up. This is on your note sheet. Use the patterns you notice to complete the tables and show your reasoning. Make sure that you discuss with your groups the answers. Don't wait until it's your turn to talk and then like waste my time and everyone else's time. Do the work, discuss, even if you don't know, that's fine, but don't just like not do it and then waste our time. 1. What is the Y value when X is 4?
Which one?
For table A.
32.5.
And class, if you disagree at any point, feel free to jump in before we get far. Table 2, what is the Y value when X is 25?
That was 5.
Oh, so you got what it is when it's 5?
Yeah.
All right, so guys, make sure you pay attention to that. That's been a trend lately. They like to start off normal and then jump to like a really high number. So they start with the x's going up by 1 so that you can see the pattern in the y. So then table 2, what's the pattern in the y? And what's it doing with the 7.5? Good. So everyone noticed that?
Yes.
It's adding 7.5 each time. It says use the patterns you notice to complete the table. But then in order to get the 25 answer, you would have to then add 7.5 up to when you get to 25. Now, is that like a good use of your time on a test?
No.
A better use of your time and what I've been trying to teach you is how to make the equations so that way you can just plug in the number, no matter what number it is, and find the output. So use the patterns to your advantage. If I'm adding each time, so table 3, if I'm adding each time, what would the graph look like for that situation? So if you're adding each time the same amount, what would the graph look like? I just asking people to do this. Not sure. Table 4. I'm not trying to get the y value right now. My question is, if I'm adding the same amount each time to something, what would my graph look like? Yes. If my y increases by 7.5 each time, what would my graph look like? Does anyone know?
Wait, like for the next number?
Straight line.
A straight line is what I was looking for. What would the graph look like if you add or subtract the same amount each time? It would be a straight line, right? What's the formula for straight lines? Table 3? Your redemption. Straight, I'm not asking what's this table's formula, just what's like the standard formula for a straight line. Y equals mx plus b, good. So for anything that is linear, or in other words, in a straight line, it's in the form y equals mx plus b. So then, what is the m and the b are what's usually replaced with numbers, right? So where would this 7.5 go if it's increasing by 7.5 each time? Would it go in for the m or the b? Table 5. The m, yes. Because the m stands for what? Slope or rate of change. So if it's adding 7.5 each time, then add it. That makes it your slope. Miss Medina. Okay, so yeah, put 7.5 where the m would go because that's your rate of change. What does the b represent, table 6? So you guys are table 7. But yes, it is the y-intercept. So what would be my y-intercept in this one, table 6? So she can't, she's thinking of this. The information for your y-intercept is in the table. You have enough information. No,
No.
no, that is not my y-intercept.
Oh,
Table 7. The question is, what's the y-intercept? Like what's the number for it?
oh,
Based on this table. Okay.
what'd you say?
Just let the one table, right, table 7, the question was, what is the y-intercept? What would be my y-intercept?
Oh,
You do have enough information here. What'd you say? It is not 7.5, that makes sense.
oh, sorry.
Table, Trenton,
Fourth side.
how do you know it's 2.5? Good. So since so many of you forgot, let us remind you,
Oh,
your y-intercept is your starting amount. So in other words, when x is 0, that's your y-intercept, your starting amount. It's where it crosses on the y-axis. So if I were to graph these, that's where it would cross on the y-axis. I think the easiest definition of y-intercept is when x is 0. When x is 0, that's your y-intercept. Make sense? All right, so now when you have stuff that is adding or subtracting by the same amount each time, put it into slope-intercept form. Rate of change is your slope, your starting amount is your y-intercept. So now I can easily find when x is 25 by plugging in the 25 where table 8. I can easily find the y by doing what now? Where? Into the x, good, because 25 is in the x column, so plug it in. Solve for the y. What is the y? Anyone have it? No one got it right the first time? Carter? 190. So here's what that'll look like in your calculator. You can put the whole thing in at once unless your calculator is not that great and makes you know the order of operations. But otherwise, that's 190 for when x is 25. Questions on that part? All right, so make sure you fix that. Hopefully you're taking good notes because that keeps reoccurring and I don't want to have you get that wrong on your notes. So table B now. Table 9, what is the y when x is 4?
Oh, 640.
640. Table 1, what is the y when x is 25?
I got like 2.81.
Right, anyone get something different?
That's the same thing I got.
2,560. Any other answers out there? Okay, so then table 2, we'll figure out which one it actually is. Table 2, what is the pattern in this one? It is multiplying by 4 each time. In one of my classes today, it was really hard to figure that out or to see that, and I get it. You're like, how else can I get from 2.5 to 10 other than by adding 7.5? Like you couldn't comprehend. But if that's not the pattern, because clearly it's not adding 7.5 each time over here, try seeing what else it could be. So it's probably multiplying by something. If that's not easy to see what it's multiplying by, take one of the numbers in the pattern, like don't take the first one, but take like the second one, and divide it by its previous number. And that'll tell you what you multiplied by to get that number. Same works if you take 40 divided by its previous number, and we get 4. That number that it multiplies by each time, and I would definitely write that down. I mean, you should be writing everything down there, right? But that number that you found is called a common ratio. That'll become important later. So your common ratio, or this curriculum also uses the word factor, so common factor is what you multiply by each time to get the next number. Questions there? All right, then instead of timesing by 4 each time until I get to the 25th time, I will make an equation, just like how we did yesterday. It's not as hard as it seems. So this over here, table A was linear, a linear function. What type of function is table B? Exponential. Yes, it is nonlinear too, but exponential is like the theme this unit. All about exponential functions. So where linear is y equals mx plus b, exponentials are y equals a times b to the x. Also those growth and decay formulas that I showed you, but this is like the standard exponential function for. So a is for your what? Starting amount. What's my starting amount? Good, so put that in your A position. You're timesing it by B, which is going to be your common factor, which we said was 4. That'll be to the x power. That's what's going into the exponent spot, all these numbers. You try it, you can test it out. When you put in 0, you do get 2.5. When you put in 1, you do get 10. But now it wants to know when I put in 25, what do I get? I definitely don't get the 2,560 because if I multiply 4 all the way up to 25 times, it'll continue to get really big. So that's just too small. This is the answer, the one that's in scientific notation, because it is so big that the calculator can't fit it on the screen. So it does times 10 to the 15. So you would move the decimal to the right 15 times, put zeros in for any placeholders, and that's how big the number is. Make sense? Okay. And then also someone brought up a good point that they have like 2.81, a bunch of numbers, and then it's e to the 15, something like that. That also is scientific notation on your calculator. So just that it's too big or too small that it can't show you. Questions there? All right, so this is a really good warm-up. Lots of connections there. We're going to do one problem and then hopefully have time to work on our practice. We'll see. Third hour, it took literally all hour. So just participate, use your group members. Camille, if you want to work with Kayla's group for this activity, you can, or just do it all by yourself. That's fine too. Okay, save the 2. That'll be the 2. So in your groups, in order to control an algae bloom in a lake, scientists introduce some treatment products. Once the treatment begins, the area covered by algae in square yards is given by this equation. I'll highlight it. Just looking at the equation, is this linear or exponential? Raise your hand if you think it's linear. Raise your hand if you think it's exponential. Yeah, it's exponential. And time is t measured in weeks. In the equation, first you're going to talk about this with your groups. What does the 240 tell us? And then what does the 1/3 tell us? So talk about it, make sure everyone in your group knows. The recorder is going to change. I won't tell you how yet. Is anyone still? Alright, table 3, what does the 240 tell us?
No, I cannot.
Can you tell me what? Let me see what I can relate it to. Okay, you remember this formula?
No.
Class, help her out. What is this formula? Exponential what? Decay. So what does the A represent? Starting amount, that's in the normal formula. What does the R represent? Good, decay rate, and what does the T represent? Time. So looking at these two equations, what position is the 240 in? Let her answer. Is it in the A, R, or T?
The A.
The A, which means starting amount, so it's 240 is the starting amount of what?
That's the me? Yes. The price for that.
Starting amount of what? Good, thank you.
Yeah.
That's it. All right, table 4, what does the 1/3 tell us? Close. Is the 1/3 my decay rate?
No.
I can see why you think that. What is it? Well, okay, yes, my decay rate is 2/3. It's not what it asked us. How did they get the 1/3? So if it's decaying by 2/3, then the 1/3 is what? It's what remains of the algae each week. I don't want you to think, that that's what it's decreasing by, because it's not, it's decreasing by 2/3. Because this is already after it's been subtracted from the 1. Does that make sense? Because it's 1 minus 2/3. Like if I have something split into thirds and I take 2 of them away, what's left? 1/3. That's how we get that number in there. Make sense? Good? Okay. Common mistake. Everyone thinks it's a decay rate, but it's what remains. The table 5, or not table 5, let me get some instructions first. In your groups, you will now graph that equation. If you don't know how, start by making a table of values. So like an XY table like this. Figure out what X represents, figure out what Y represents, either area or time. And then it wants you to figure out the area when T is 0, 1, 2, 3, and 4. And again, the equation is given to you. So that's all the hints I'm giving you. Try it out with your groups. Give you 2 minutes. Okay, that's fine. Table 5. What is my Y value when X is 0 for this situation? 240. Table 6. What's my Y value when X is 1? Or when T is 1? So table 6, that's my grant table. What's the area? Because Y is for area. T is for time. What's the area of the algae at 1 hour? All right, and class, if you disagree, just jump in at any time. Table 7, what is the area when the T is 2? So really the skill that I'm testing you on is if you can use a calculator. So in this unit, you have to know how to use a calculator. There's just no way. I don't know how to do this math in my head, and I've been teaching the same lesson every year for a long time. Answer, Emery? 26.7. Table 8, what did we get for number 3? What'd you say? 8.8. Table 9, what is the y when x is 4? Okay, so let's see. So again, the skill I'm testing you on is can you use a calculator? And round, I guess, because rounding, sometimes you have to do that too. So 240, listen, everyone look at the screen now. Times 1/3 to the 0 power is 240. To the first power is 80. To the second power is 26.7 if you round to 1 decimal spot. To the third power is 8.9 if you round to the first decimal spot.
Whoa, guys, whoa.
And then I don't think they're talking about, I think they're talking about something else. And then to the fourth power is 2.96. But if you round it to 1 decimal spot, what does it end up becoming? The overall answer ends up becoming 3. Because to the right of the 9 is 6, you would round up, but you can't go higher than 9, so then you round up the other parts. Does that make sense? Okay, but close. A lot better answers than I was getting earlier. Now put that on your graph, but you have to decide what's an appropriate scale. So like, what should we number the tick mark by? Listen, we're probably behind you. I want you to be at least on pace with my other classes. So x-axis is for what in the situation? The time in weeks. And here's my x value. What should I probably count by? Good. I would count by 1. I probably won't label every single number because I don't have room to, but they're counting by 1. Or at least that's what I want. The y-axis represents what in the problem? Table 1. What does the y-axis represent? The area of the algae. And these are my numbers for the y. Since my biggest number is 240 and my smallest is 3, what should I probably count by? You did it by 20s, 15, might work, I don't know. 20s, I know for sure work. So 20, I'll label every other one. 40, 60, 80, 100, 20, 40, 50, 80, 200, 20, and then, you know, I labeled every other one just because I can't write that small, but we're counting by 20. All right, now graph your points. 0 to 40 would be here. 1 up 80 would be there. 2 up 26. I need to look at my screen. would be like right, no, not that one. It would be like right there. 3 up 9 would be here-ish, and then 4 up 3 would be here-ish. Everyone see that? Okay. Now tell me about how many square yards will the algae cover after 2.5 weeks? So someone said about 20. What'd you say, Tyson?
Nope, I didn't really know.
Okay. Anyone else? Care to throw something out there?
15.3, 15.4 yards.
Okay. So you could plug in the 2.5 and get an exact answer, but it said about, and the book says answers may vary. So they were just going off of the chart. So you see how 2.5 would fall between here on the X's? Well, then it would be somewhere between these two answers. So 20 could work. 15.4, I think, is what you get when you plug in 2.5. But I think it takes a full week for the treatment to reduce it by a full season. So it could vary. It could be anywhere from like 27-ish to 9-ish is what that says, based on the graph. Good, any questions? All right, so really that's all I have for you. I prefer you not pack up yet, for you to do your practice a little bit at least. Try to have your practice done by the time you walk in on Monday, so we can go over some answers. Or yeah, Tuesday, whatever day. I guess Martin Luther King Day.